Yeah, I hate them after
After the break is exam 4. You do the quiz today, and then on Monday we can go over the quiz mistakes. Then Wednesday is the exam. See, you're gonna be very busy. Okay. So yeah, we already went over the quiz 5. Did you watch the recording?
Yeah, I did that.
Yes. So homework 9 and quiz 6 is due tonight. And you know the homework you can submit your first attempt, but if your score is not good, it's okay. You can after the due date you can also do your homework and improve your scores. Okay? But the quiz you have to submit by midnight. Then I will grade the quiz over the break. We will go over the quiz mistakes and the quiz solution on Monday. So then the exam is on Wednesday. Okay, everybody? And then homework 10 is due Friday. Can you see we only have 3 weeks left? So you're gonna be very busy. So I hope over the break, you can enjoy your time. Also, you can study for the exam. And also like review all the period stuff, also work on homework 10. And then we only have like 2-3 weeks left. Okay, so let's see here. Okay, so if you go to the Blackboard and you go to My Grades, then you can see all your scores. And then you see the homework average. So we have 11 homework and we dropped the 2 lowest one. Okay, by the way, this final exam review is an optional exercise. It's kind of a review of what you've done so far. Okay, so you can use it as a exercise, extra exercise. So 11 homework, we dropped the 2 lowest. So if you submit homework 9 and you get all the perfect scores, then your homework grade will be 100%. And you don't have to submit homework 10 and homework 11. But I would say if you want to do well on the final, you better do all your homework. Even though you don't need to turn in 2 of them. So do all of them. And we will have how many quizzes? We have 7 quizzes and we will drop the 2 lowest. Okay, so tonight you would submit quiz 6 and we will drop the 2 lowest. So, and then please turn in your practice exams and exam correction and wrappers. So if you miss some of them, please submit them as soon as possible. Okay, and it will show the homework average, and I will also create an item is about like quiz average, and then another one score is a self-assessment average. Then you can see your scores and like calculate your grade. Okay, so last time we finished 6.6, and I can tell you exam 4 will be the hardest exam in this course because it covers a lot of application problems, like the word problems, real life story. It's hard because you don't know like what formula we're gonna use, and it really based on the story. You might see a circle, you might see a square, you might see a cylinder. It's a lot of possibilities, right? Yes. Today we talk about 7.1. No, you have to memorize. Yes. Okay. So, but try to understand it. When I introduce those formulas, I show you how to derive those formulas. Do you remember? Like a parallelogram, if you cut this part, put it there, you get a rectangle, right? And triangle, you have 2 copies, then you get a parallelogram. And also, that's why the area of triangle is 1/2 of the area of parallelogram, base times height. So when we talk about those formulas, I actually derive. So you can understand the formula instead of just memorizing it. So please watch the lecture video on that day, 6.1, right? Is it 6.1 where we go over those formula? Yes, we talk about how to get those formula. Okay, so today let's look at section 7.1. Did I start the recording yet? Let me see. Is it recorded? Okay, yes, it is. Okay, so we have been doing derivatives. Now is the second half of calculus, integration, or you can say anti-derivatives. Okay, integration overview. Okay, functionally speaking, integration is the inverse process of differentiation. So here I have an analogy. You know, division and multiplication, right? Division is the inverse process of multiplication. The process is called dividing. And mathematical notation for division. What is 10 divided by 2? Okay, we want to find what is 10 divided by 2. And then you think of, oh, this is the same as saying 10 is 2 times x. And then you think about what number x we can find so that 2 times x is 10. And then by experience, we know 2 times 5 is 10. Right, everybody? This is how we divide numbers. And we call x is the quotient. 10 over 2 is called a fraction. Right, everybody? Okay, use the similar analogy. Integration is the inverse process of differentiation. So this process is called integrating. So you have differentiating and integrating. They are inverse process. Mathematical notation for integration. Well, you have this looks like as. It actually represents the sum, okay? And you have the dx at the end. So your function is in the middle. Think about a sandwich. You have this is like an as, okay, the on the left, and then your function is in the middle, and you have the dx on the right. So this is the notation of integration. There is a reason why we have such notation. So when we go to section 7.3, we will talk about Riemann sum for integrals, and then I will explain why we have this notation. Okay, so this means the integral of the function a times x squared with respect to the variable x equals to capital F of x. So this means we find a function f of x such that the derivative f of x equals to ax squared. Do you remember what is derivative? The slope of a tangent line, right, everybody? Derivative, it represents the slope of the tangent line at a point. That's why this notation, is a slope. So change of y over change of x, right, everybody? That's why we have dy dx. That is the derivative. And then, so derivative represents the slope of the tangent line. How about antiderivative or integration? What meaning? The meaning is this represents the area under the functions. Okay, everybody? So this represents the area under the function. All right. And then, okay. So, and we realize that when we differentiate attendance, okay. When we take the derivative, our power dropped down by 1, right? So look at this. If we take the derivative, a is like a constant, so a over 3 is right here. Derivative of x cubed is 3x squared. Derivative of c, a constant, is 0. Right, everybody? So when we simplify, the 3 and 3 cancel, we only left with ax squared. So we want to find a function such that the derivative of that function is ax squared. Well, this is a function. And we call f of x is the antiderivative.
Idea.
Yes, a over 3, because when you take the derivative, the constant multiple stays here. And the derivative of x cubed is 3x squared. We're taking the derivative. The derivative of a constant is 0. So when you cancel the 3, what's left? Ax squared. Okay? So we just check that the derivative of this function is ax squared. Therefore, this function is called the antiderivative of ax squared. Okay? And this is called a indefinite integral. Okay? And yeah, we'll talk about what is indefinite integral and what is definite integral. So right now, you can just put integral. Okay, so here, you kind of think backwards. It's like, okay, I'm your teacher, then you're my student, right? So ax squared is the derivative of a over 3x cubed plus c. Then this guy is the antiderivative of ax squared. Okay? Yes. Okay, so how about let's review our formula. Okay, let me open. So do you have a paper? Take out a piece of paper. No? Any paper? Okay. Let's see. All right. Maybe at the back of your worksheets. Yeah, at the back of your worksheets, you have a paper. Okay. So let's review all the derivative formula. Okay, we have the derivative of a constant is 0, right? By the way, leave some space on the right side. And we also have the product rule. Remember, 2 students go to the restrooms. They go one by one. U prime v plus uv prime. Yes, everybody? And then quotient rule. We have u prime v but minus uv prime over v squared. Yes, everybody? And then we have chain rule. So chain rule. So dy dx is dy du times du dx. This is chain rule. Okay. And then formula, derivative formula. Derivative of x to the n prime. What is that? What's the derivative of x to the n? Down J? X to the n minus 1, but you multiply by n in front. Yes, everybody? And how about e to the x derivative? E to the x. Yes? How about e to the kx derivative? K e to the kx. Be careful. Don't put kx. It's only k. K times e to the x. E to the kx. Okay, everybody? Don't put the x here. Okay, the x is only the exponent. Don't put it down. How about b to the x? Remember I said father looks like the son, but father has the mustache? Yes. So it will be b to the x. Father looks like the son, and the mustache is LMB. Do you still remember? Yes. So yeah, we learned the derivative formula in exam too, but you also need to know this formula for exam 3 and 4. Okay, because application of derivative. Well, the first thing you need to know the derivative, and then you can play with that, right? And you can apply this to other real life problems. But knowing the derivative formula is really the foundation. Okay, and then we also have natural log of x. What's the derivative? 1 over x, exactly. And if we have other base, then it's going to be 1 over x. And then remember, you divided by L and B. So always remember those two. Okay? Derivative of exponential function, we multiply by L and B. But the derivative of the logarithmic function, we divide by L and B. Okay, so very good. Let's continue. So that is the derivative formula. Okay, so we review that. So today we're gonna talk about the antiderivative formula. So keep this paper for now. Let's continue with our worksheet. Okay, geometrically speaking, integration is finding the area bounded by a function and the x-axis and two vertical lines at fixed x values. So this is a definite integral. Okay, definite integral. You have the bounds for x, and you can see this picture. The area under the function x squared, where x goes from 1 to 2. So this is the integral. The x goes from 1 to 2. So you put the left. This is called the limit of integration. You put the left limit down, and then you put the right limit up there. Okay, so it's integral from 1 to 2, and the function x squared dx. And how do we get this area? We find the antiderivative of x squared, which is, we just show that if we have ax squared, then the antiderivative is a over 3 x cubed plus c, right? We just show that. Therefore here, if we only have x squared, it's like the a is 1, right? Therefore the antiderivative a is 1, so you get 1/3 x cubed plus c. So that is the antiderivative. And you plug in 2 first, so you plug in x is 2, and then subtract, you plug in x is 1, and see, you plug in 2, you get 1/3, 2 cubed, 2 cubed is 8, and then plus c is any constant, so because it has no x, so that's why c, it remains c here. Subtract when we plug in 1 for x, the c is 1/3, x is 1 cubed, and then the c remains here. Ooh, when you break the parentheses, you get 8 over 3 plus c minus 1/3, and then minus plus become minus c. And the c cancel. 8/3 minus 1/3 is 7/3. So the area of this region is 7/3. You get a number. Questions?
So we add 1 to the x squared and 3 to
We add 1 to the x squared. Okay. So we will talk about all the antiderivative formula. Yes, later on. We'll talk about the antiderivative formula. Yes, you're right. It's whatever power up there, we add 1. Because every time you differentiate, your power jumps down by 1. So when you integrate, the power increase by 1. And then you divide it by the new exponents. Yes, we will talk about all the antiderivative formulas later. But right now, I just want to give you an idea of what is the integration. A represents the area under a curve. Okay? So this symbol, S, stands for sum, because the shaded area is calculated by partitioning the region into an infinitely many number of little rectangles. So you can cut into many rectangles, and then you can use the area of those rectangles to approximate the area, and then you let the number of rectangles goes to infinity, then the area will converge to the this integral. Okay, everybody. So we will talk about this in session 7.3. The Riemann sum, the true definition of it. We'll talk about that in 7.3. Okay, definition. A function, capital F. We usually use capital F stand for the antiderivative of the small f. So capital F is the antiderivative of the small f. So small f is the derivative of the capital F. Is that okay, everybody? It's like I'm your teacher, then you're my students, right? The role are different. Okay. So let f be any antiderivative of the small f. Then all the antiderivative of small f have the form of the capital F of x plus c. So plus c, it means you shift the graph of f either up or down. So you get a family of functions. Is that okay, everybody? When you add a number, it's like shift up the graph, right? When you subtract a number, you shift down the graph. So this represents a family of functions. Okay, so your antiderivative, you actually get a family of functions. Because when you take the derivative, do you see the derivative of a constant is 0? Right? That's why you add the c or subtract c. When you take the derivative, the c go away. You have the same derivative. Okay? So that's why all the antiderivative is a family of functions. Okay. And notation. The df dx represents take the derivative of x. Because derivative is the slope of tangent line. Here you have change of y over change of x. Exactly, it's the slope. Right, everybody? And then the notation to find the antiderivative, we have the sum and the dx. The function is in the middle. Everybody okay with this notation? Think about a sandwich. You have the s and the function in the middle, and you have dx at the end. So it has three parts. And f of x is called the integrand. X is the independent variable, or you can say it's the variable of integration. Okay, now let's talk about the rules. All right. So here for the derivative, do you remember if you have a derivative of constant multiple, then you just move the constant in front of the derivative, right? So maybe I should put it here. So if you have c times f prime, this is just c times f prime. And if you have f plus g prime, this is f prime plus g prime. Right, everybody? So for antiderivative, okay, let's use a different color. For antiderivative, integral of c times f dx is going to be c times integral f of x dx. So for constant multiple, you can move the constant multiple outside of the integral. So far, so good. Everybody? And for sum, integral of f plus g dx is the integral of f dx plus the integral of g dx. So for sum, you can also split. All right, everybody? You have your paper? So to do it, two parts. That's what I want you to see. Okay, on this side, this is the derivative. On this side is the antiderivative. So you can compare. Okay? Find the relationship between them. So it's not like new formula. It's the same old formula, but you think backwards. Okay? Let's continue. All right. So let's go up there. Yes. Integral. So in this case, derivative of c is 0. Therefore, integral of 0 is going to be a constant c. Does it make sense, everybody? The derivative of c is 0. The integral of 0 is the constant c. And for product rule, quotient rule, no product rule or quotient rule for integral. Okay? So if you see a product or quotient, you must be able to simplify. So you get the integral of a sum or difference. So you don't have product rule or quotient rule for integral. If you have a product or quotient, you must be able to simplify so you get a sum or difference. And for sum and difference, you can integrate each term. Is that okay, everybody? So, yeah. If you have products, but think about it, maybe distributes, or a quotient, split those two terms, and maybe you can cancel something. Okay, so yeah. And for the chain rule, okay, so for the chain rule for derivative, we have something called U substitution, and which we'll talk about that in the next class, next week. Okay, so in 7.2, we'll talk about U substitution. And now the power rule. See, when you take the derivative, your n decrease by 1 and you multiply by n. Therefore, you want to find what is the integral of x to the n. Okay, think about it. Let's try to derive. Oh, when you take the derivative, the power decreases by 1. Then when you take the antiderivative, the power is going to be increased by 1. Right? We're trying to find, okay, we want to find, oh, okay, what is that? Such that the derivative is x to the n. Okay, let's try xn plus 1. Do you see when you take the derivative of x to the n plus 1, you get n plus 1 times x to the n. Yes, everybody? But I want my result to be exactly x to the n. I don't want to see the n plus 1. So now both sides we divided by n plus 1. Then we get, the derivative of x to the n plus 1 over n plus 1 is x to the n. Therefore, my integral of x to the n is x to the n plus 1 over n plus 1 and then plus c. Antiderivative is a family of functions. So you plus c here. So this is how we derive. Okay? Antiderivative. The power increased by 1. And then you divide it by the new exponents. Okay, everybody? So why do we do that? Because we get rid of this n plus 1 when we take the derivative. Okay, next. The derivative of e to the x is e to the x. Therefore, the integral of e to the x is e to the x. Yeah? E to the x is so special. The derivative and the integral is itself. But you need to add the plus c, right? It's like plus your cell phone. You carry your cell phone all the time. Okay, next. How about the integral of e to the kx? Now let's see. You want to figure out what such that the derivative is e to the kx. But do you see here? You can both sides divided by k. Yeah? You can both sides divided by k because you want your right hand side. You want the derivative is exactly. Oh, sorry. I don't need to do the prime because I'm using the both notation. No. Okay. We want the derivative to be exactly e to the k. Therefore, this function should be e to the kx over k. Is that okay, everybody? Because we want to have e to the kx. That's what we decided. This is the idea. Therefore, the integral of e to the kx is e to the kx divided by k. And you think of the derivative and the antiderivative, they are inverse process. So the derivative is you multiply by k, and the antiderivative you divide by k. Right, everybody? So far, so good? Okay, so yes, write this down. Okay, so if you forget about the formula, you can deduce the formula. So we not just memorize the formula, we understand it. Okay, let's continue. How about the integral of b to the x? You want your right hand side to be exactly b to the x. Yeah, everybody? Which means you want to get rid of L and B. So both sides you divide it by L and B. Okay, everybody? So therefore, you get B to the X over L and B plus C. Okay. So, yeah. So this is how we derive this formula. Just watch the video. This part is okay. All right, keep going. The derivative of ln of x is 1 over x. Well, the integral of 1 over x is then, any guess? ln x. Actually, it's ln of absolute value of x. If you can remember when we talk about the derivative of log x, we also talk about the derivative of our absolute value of x is 1 over x. So therefore, the integral of 1 over x is natural log of absolute value of x plus c. Is that okay, everybody? Right. And so usually you would see 1 over x. Usually, when you have something else here, you can just so yeah, you don't need to do the integral. If this one, then you can just use this one. So it will take care of this. Do you know what I'm saying? I'm saying that if you have something like 1 over x, 1 over L and B dx, you can just move the L and B as a constant multiple and move it in front of the integral. Then you just get what? Integral of 1 over x dx is ln absolute value of x plus c. So you only need to know this formula. You don't need to do differences for this one. Okay? So that's why this one you don't need to remember. It's just this one. It will take care of all the log functions. All right, everybody? Okay, and then we also talk about constant multiple. We can move the constant in front of the integral. And for sum and difference, also true for difference. Then you can move them, separate them. Okay, so everybody okay with this formula? So keep this paper with you. 7, you're going to need that. Okay, it has the derivative formula and the anti-derivative formula. Okay, so take a picture. Oh, yeah, take a picture of it. Yeah, so the recording has how I derive the formulas. So if you kind of forget, please feel free to watch the recording. Let me also save that. Okay, I can save to, let's see. Okay, I can maybe save later. Cancel. Okay. All right, so that's why here we have the formula. Yeah, integral x to the p. You increase the power by 1, and then you divide it by the new exponent. This power rule only works if p is not exactly minus 1. Because if p is minus 1, you actually get the integral of 1 over x, right? 1 over x is not a power function. It's the logarithmic function. Okay, so this is special. For other power, you can use the power rule. But for 1 over x, it's using the log out absolute value of x. And then, yeah, these two formulas as well. Okay, let's work on examples. All right, example 1. We want to find all the antiderivative of this. Oh, okay. Sorry. I think I have some typo. We haven't talked about the trig function yet. Okay, let's change this problem to 5e to the 7x. Okay, so in applied calc 2, we'll talk about the derivative of trig functions and antiderivative of trig functions. Okay, but for applied calc 1, yes, we didn't talk about trig functions yet. Okay, so we want to find the antiderivatives. So integral f of x dx is the integral 5e to the 7x and minus, see, this is a quotient, but we don't have quotient rule. So if you see a quotient, simplify it. Split the numerator. You see, it's actually ax squared over 9x to the 4. And then when you split, because this is minus sign, and then minus times plus becomes minus. And then the second term on the numerator is 7. What is square root of x? X to the 1/2 over 9x to the 4. Okay. And then dx. Okay, the antiderivative. 3 parts. Sum, and then our function, and then dx. If you have a quotient, express this in terms of sum or difference. No quotient rule, so simplify it. Okay, do you see the x's on top and the numerator? We want to combine them. So we want to use the power rule, and we need to combine them. How about let's split them? So this is the 5 integral e to the 7x dx and minus, do you see this is like minus 8 over 9? Oh, maybe let me simplify it first. Okay, don't split them yet. Okay, let's simplify it. So we can group the coefficient together and then group the x power together. Do you see this x power is like 2 minus 4? And then minus 7 over 9. So group the coefficient together and group the x power together. This is 1/2 minus 4. Okay, so when we simplify them, we group the coefficient together. and then group the x power together. All right, so what is this? Okay, now we can see this is integral 5 e to the 7x minus 8 over 9. And then, what is 2 minus 4? Negative 2. And minus 7 over 9. What is 1/2 minus 4? Negative 7 over 2. Good. Dx. So this is how we simplify it. We integrate each term. Now we integrate each term. Okay, so be familiar with the formula. The first term, what is your formula of e to the 7x? Which formula do we use? E to the 7x? Yeah, ekx. The antiderivative is e to the, what is k? 7x divided by 7. And then the 5 is like constant multiple. So it stays here, right? So 5 stay here. And then the integral of e to the 7x is e to the 7x over 7. That's the first term. The second term, do you see constant multiple? Just stay here. Right, everybody? And x to the negative 2. See? X to the negative 2. As long as that power is not negative 1, then you're going to use the power rule. Right? So we use the power rule. X to the negative 2 is x to the negative 2 plus 1 is negative 1. Yes. So we have x to the negative 1 over the new exponent, which is negative 1. Every time how I do it, okay, copy down the coefficients, constant multiple, and then multiply by, you increase the power by 1. So negative 2 plus 1 is negative 1. Okay, then you divide it by the new exponent, which is negative 1. And then the next term, constant multiple, stays here. Okay, the power, you add 1, what do you get? Negative 5/2. So we divide it by negative 5/2. Right, everybody? And every time after you integrate, please plus c. Okay, because the other antiderivative, they are different by a constant. You need the plus c. Okay, so we got simplify 5 over 7 e to the 7x, and then minus become plus 8 over 9 x to the negative 1. And do you see this part? When you divide it by a number, it's the same as multiply by the reciprocal. What's the reciprocal? You flip the 5 and 2, you get 2 over 5. Right? When you divide it by a number, it's the same as multiply by its reciprocal. And then minus cancel. Ooh, so it's plus. What's 2 times 7? 14. What's 9 times 5? 45. And this is x to the negative 5 over 2. And then plus c. So this is the final answer of example 1. Any questions about example 1? No? Okay, let's look at example 2. So our integral f of x dx. See? We have those two terms. And we're ready. It's the last problem. We need to do something else because we have this quotient. we don't have function group. That's why we need to simplify it. But in this case, both of them are in the group form. We can go ahead and integrate it. Right? Look at the first term, e to the minus 10x. Which formula do we use? Yeah, e to the kx. So we got e to the kx. K is minus 10x over what? Negative 10. Yes. And do you see 4 over x? You can think of this as like 4 times 1 over x. 4 is constant multiple, right? Leave it there. And what is the integral of 1 over x? ln. Yes, exactly. Is ln absolute value of x. And plus c. Ooh, that's it. For this problem, that's it. Is that okay, everybody? Yeah, so look at each term, okay? Each term that is a good form. Are we ready to use the anti-derivative? Okay. All right. Okay, now everybody do example 3. Okay. So let's first do, so you can see example 3. We find the f such that the derivative of f is the following. And we know f of 0 is 1. So this is an equation containing derivative. Okay? So this is called a differential equation. It's an equation containing some derivatives. And the information f of 0 equals 1 is called the initial condition. Do you see when we integrate, we have a family of a constant c? Okay, so it's a family of functions. This initial condition can help us to figure out what the c is. So when you plug in the initial condition, you will get c is a fixed number. So how about you guys just find, okay, so f of x is integral of the derivative. Okay, so it's integral 5 e to the 2x minus 4. Let's put this in the standard form. What is the power? Square root of x cubed. Is x to the 3 over 2. Yes. And plus 7. Okay. So everybody differentiates. I want to see if you figure that out. What's the integral of x e to the 2x? Okay, so let's continue next week. And remember today you have homework and quiz. Okay, so do your quiz before midnight. And happy Thanksgiving! Thank you. Will you eat a big turkey?
I don't know.
Oh,
I don't like
okay. I like steak. So yeah, exam 4 is on Wednesday. Okay. So yeah, study chapter 6, do the practice exam, and yes, come to ask me questions.
Okay, the officer.
My office hours is from 1 to 1:50, and also in the afternoon from 3:15 to 4:15. Do you have time? Yes. Okay, great.